Right, so the next sort of series of videos is going to be all about stoichiometry, which is just a fancy word for using a balanced chemical equation, or the ratios really from a balanced chemical equation. So the idea is just that as long as you know an amount of something in that reaction or that balanced chemical equation, you can find an amount of anything else that you want. So you may be given an amount of a reactant and ask for an amount of a product, or an amount of a product, ask for an amount of a reactant or another product. But as long as you have your balanced chemical equation and you know an amount of one thing, you can find an amount of anything else. So just using a balanced chemical equation. So at the very top of the sheet here, you can see there's an example of a reaction or balanced chemical equation. So we have 2H2 plus O2 yielding 2H2O. So if I asked you to read this out loud to me, you might say you have 2 molecules of hydrogen reacting with 1 molecule of oxygen to produce 2 molecules of water, which is true. You could also think of it, though, as moles. You could think of it as 2 moles of hydrogen reacting with 1 mole of oxygen to produce 2 moles of water. So your balanced chemical equation, what it gives you is a mole ratio. Right? When it says 2 moles of hydrogen react with 1 mole of oxygen, that means it's a 2-to-1 ratio of hydrogen reacting with oxygen. Okay? And that's the information you can use, that ratio, to find an amount of anything you want as long as you have an amount of something else, which sounds a little confusing. So let's go into an example. Okay, so in the first example, it's sort of the most straightforward stoichiometry question you might get asked. So it's just if you have, it says if you have 3.62 moles of N2H4, how many moles of N2 are you going to need? So you're given moles of one thing, you're asked for moles of another. Okay, and you're also in this case given a balanced chemical equation. So with stoichiometry questions, you'll notice you'll always be given an amount of something, and asked for an amount of something else. And you may be given a balanced chemical equation, or you may have to write it yourself, but you're always going to need a balanced chemical equation. And again, you're always going to be given an amount of something, asked for an amount of something else. So in this equation, or in this question rather, it's nice because we've already got the balanced chemical equation. Good idea though, whenever you're given a reaction, just double check that it is properly balanced for you. Okay, so we have 3.62 moles of N2H4. We want to know how many moles of N2O4 is going to react with that. So we're given an amount of one of our reactants, the N2H4. We have 3.62 moles. And we're asked rather for an amount of our other reactant. So we want to know how many moles of N2O4 are going to react with that. So if you look at the balanced equation, they react in a 2-to-1 ratio. So we're going to need half as many moles of N2O4 to react with our N2H4. So what I'm going to do is just write that out. And I'm going to use a conversion factor to solve this problem. So if you've watched the other videos, I've mentioned conversion factors before, and all they are ratios or fractions that allow us to convert from one unit to another. So in this case, we're going from moles of our N2H4 into moles of our N2O4. So I've written out what we have. We have 3.62 moles of N2H4. So in my conversion factor, what's going to go on the bottom is what I have and want to cancel. So I have moles of N2H4, so that's what's going to go on the bottom. What I'm going to put on the top is what I want, right? So what I want is moles of N2O4. So again, remember with stoichiometry, our balanced chemical equation gives us a mole ratio. So as long as you have moles of something, you can find moles of anything else. So on the bottom, I have the moles that I was given and want to cancel. On the top, I'm going to put the moles of what I want. I want to know how many moles of N2O4. Okay, and then the numbers that I'm going to use for the conversion factors for stoichiometry are just the coefficients from my balanced chemical equation. So I know that 1 mole of N2O4 is going to react with 2 moles of N2H4. Right? And again, I like to show things canceling, so I know in the end my answer is right. So I'm going to cancel moles of N2H4. I'm going to be left with moles of N2O4, which is perfect. That's what I want. So when I do the math, I have 3.62 times 1 divided by 2, which is going to give me 1.81. So I have 1.81 moles of N2O4. Okay, so stoichiometry, long, fancy word, but all it is using the mole ratio from your balanced chemical equation. And the way you solve all stoichiometry problems is, I'm just going to write this out here, you might want to add it to your notes. You have to start with a balanced chemical equation. So you might be given that, or you might have to write it yourself, and you'll see that in some future examples. So first step always is to write balanced chemical equation. Okay. The second step, now in this question, we were given moles, but you may not be. You might be given a mass. So we could have been given a mass of N2H4 instead of a number of moles, or maybe even a number of molecules of N2H4. But the key part to stoichiometry is that the balanced chemical equation gives you a mole ratio. So if you're not given moles, your next step is going to be to take what you've been given and convert it into moles. So convert given amount, I'm going to say, into moles. So in this particular example, it was already in moles, so we didn't have to do that. We could start right away and use our stoichiometry or balanced chemical equation right away. But if you're given a mass or if you're given a number of molecules, you have to convert it into moles. Then the third step is going to be that stoichiometry part. So use the mole ratio from your balanced chemical equation. I'm just going to say your chemical equation, it has to be balanced, so remember that, to find moles of what you want. Oop. So to find moles of whatever you're asked for. I'm going to call it required. So whatever you're asked for, whatever the question is asking you about, and it could be a reactant, it could be a product, but whatever it's saying, an amount of whatever you're looking for, you want to use that mole ratio to find the moles of that. So in this question, we were looking for moles of N2O4. Okay, and in this question, that's all we wanted. We wanted moles of N2O4. So we just had to use the ratio and we were done in one step. But you may have a question where you're asked for a mass of, N2O4. We could have been asked for a mass of N2O4 or a mass of something. Or even, again, a number of molecules of something. So if that's the case, then you have another step that you're going to add on, which is going to be to convert from moles into whatever unit you're asked for. So if you're asked for a mass, you have to convert into grams. So you're going to need to use your molar mass. And we'll go through some examples in a future video. Okay, so stoichiometry, you're just using the ratio from your balanced chemical equation. So make sure that you have a balanced chemical equation to start with. So you may be given one, you may have to write one, but start with a balanced chemical equation. Then you need moles. So if you're given moles, perfect, you can start. If you're not, if you're given a mass, you're gonna need to convert into moles. Okay? Once you have moles of what you were given, great, that's when you're gonna use that ratio from your balanced chemical equation. So remember, what goes on top are the moles of the substance you're being asked to find, and what goes in the bottom are the moles of the substance that you've been given. And the numbers are the coefficients from your balanced chemical equation. Okay, so you're going to find the moles of whatever it is you're looking for. And then the last step, if there is a last step, is going to be to convert from moles into the unit that you've been asked for. Okay, so in our next video, we'll go over an example where we're given a mass and we're asked for a number of moles.